Hello everybody, I'm Nick, and in this video I'm going to show you how you can get started with using DynamoDB for your .NET applications. In this case, we're going to see how we can use it in an API, a REST API. However, I'm going to approach this differently. Instead of just starting from nothing and using DynamoDB, I'm going to show you how you can migrate to DynamoDB and show you how easy it is, but also how you might have some limitations around your design and how you can get around them. I'm also going to explain how NoSQL databases work, like DynamoDB or Cosmos DB or Mongo, or all of the partition-based ones, and explain why those limitations are in place and why they are what effectively allows us to scale to such a huge amount of data and throughput. Now, this video is sponsored by AWS, and they're kind enough to offer all of you watching this video $50 worth of AWS credit as long as you use the link in the description to sign up and you put the text you see right here in the description box. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell, and for more training, check out nickchapsas.com. All right, let me show you what I have here first before we dive into any DynamoDB stuff. So I have an API, and I'm not going to show you all the details. Just know that it uses this customer controller to expose my customers in the system, which are stored in a Postgres database currently running on my machine in Docker. And I'm going to show you what this looks like from the consumer perspective. So I'm going to just debug this API, and it is running. And I'm going to go here and I'm going to create a customer. So you can see I create Nick Chapsas over here. I have a post request on the customer's endpoint. I call that, and Nick has been created. And I can see that because when I call the get all customers endpoint, I can see myself being returned. Then I can get myself based on the ID, so I can get that. I can also update myself, so I can put the ID of my customer here myself, and then change my date of birth for the 1st of 1st to another one. And this now updates myself. You can see the updated version here. And if I go and get all, you can see the date updated, and then eventually I can delete it just to prove that this is on a real database. I'm gonna go ahead in Rider and use the Postgres integration to see my data and my ID. So I'm going to say username and password. The username is Nick, the password is Chapsas, and my database is called MyDB. So I'm gonna test the connection to make sure it's fine. Yes, it is, and then okay. And if I expand here, I can see my customers table, and I can simply say select everything from customers and run that. And as you can see, I am here. Let me just make this smaller. All the data you see are in a real database, and that's it. And then in the end, we can delete it. However, I did stop the API. So let me just start it again. Customer deleted. And that's it. That's the API. We're going to be introducing DynamoDB and replacing Postgres. Now, the good thing about this API is that I'm using a repository pattern because I'm not using anti-framework. I'm using Dapper. So I can actually use the same repository and replace my data stuff without having to break the repository itself, which is also a good example of how repository can actually help you in some scenarios. Now, it's not the solution to everything, but in this case, it will actually help me. Now, let's first remove the things we don't want to use. So the first one that we don't want to use is anything Postgres and Dapper related. So I'm going to go to the program.cs and remove Dapper and remove also the Postgres package. And now some things will break. For example, all these queries that will break. This DB initializer that runs some migrations in the beginning will not be needed at all. So I can delete that. And this DB connection factory that creates a connection for that specific handling isn't really needed either, because the connection to DynamoDB will be in a separate singleton that we inject into the repository. So I can delete that folder altogether and this constructor as well. Now I'm gonna go ahead and delete all the implementations for these methods because I don't need them. Here we go. Everything is deleted. And then the program.cs, delete the reference to the database stuff, delete the service registration, and then also delete the migrations down here. Again, all this code you're seeing right now is in the description down below because AWS is sponsoring this video, so I can provide it for you for free. And now with all that, we can start into replacing what we have here with DynamoDB. Now, before I show you the code, I want to go to the portal and create the table that I'm going to call to DynamoDB from my API. So I'm gonna go over here. This is the AWS portal. If you have used the link in the description, you probably have this view in front of you, and you can go here and say DynamoDB. Now, for context, I've used DynamoDB extensively with terabytes of data and billions of documents with great success, but it's one of those things that the data modeling itself is super, super important. I'm not going to cover data modeling in depth in this video. If you are interested in a data modeling video, let me know and I'm going to make one, because it was actually one of my favorite parts of working with DynamoDB. And I can go to either create table over here or tables and say create table over here, and I'm gonna call that customers. Now, there are scenarios where you can just use a single table for the whole system, and this works fine. However, data modeling gets a bit more complicated and elaborate, so I'm just gonna use one table for this entity. However, this is not really how, the big companies do that type of thing. They usually use less tables and they share the real estate of the table for some very good reasons, actually. But this is also totally fine. You're not really missing out on anything, but you don't need to have one table per entity. A table is like a database in DynamoDB. And then we have the partition key and the sort key. And these are super, super important. In fact, it is what really makes or breaks your data modeling. Now, I don't want you to think the partition key as necessarily the primary key. It's not like that. But to explain what those two things are before I create the actual table, because you need to have the context, I'm going to bring my surface and show you a bit of diagram to explain how partitioning works in databases like DynamoDB. Okay, so let's talk about trains. Let's say I have a train and I have a bunch of different wagons. So I know my painting skills are bad, but let's just hang in there. So these are wagons of a train, and you have more over there and you have more over there, but we're only gonna focus on this. And we deal with the train as a single entity. So we have the concept of the train. And we have the doors, and you might also have windows, whatever. But we're gonna focus on these parts of the train over here. And then we have some person over there. And this person is responsible for everything that has to do with the train until the train departs. Now, this is a train I usually on board. And sometimes on a Monday, I might go here. On a Tuesday, because there might be more room here, I might go here. And then some other day, I might go here. What I'm trying to say is at any given train ride, I could be in different places in the train. However, sometimes my mom comes to the platform and she says to that person over here, hey, Nick forgot his bag, so you have to go find him and give him his bag. So now what this person needs to do is try and find me and go here and say, hey, is Nick Chapsas here? No. Okay, scrap that. Let's go here. Hey, is Nick Chapsas over here? No. Oh, damn. Okay, maybe is Nick Chapsas over here? No, Nick Chapsas is not here, because Nick Chapsas was actually here because that's where he happened to have been. Now, this person's approach to finding an individual on a train is very inefficient, because since a person can be on any wagon, you have to search all the wagons, and on average, as more wagons are added to the train, the harder it is and slower on average to find the person. Sometimes you're gonna be lucky and I'm on the first wagon, but sometimes I'm gonna be on the last and you're gonna have to search all of them before you find me. But what if this train company had a policy that each person, based on their first name, has to board a specific wagon? So everyone whose name starts with K goes here, L here, M here, N here, and so on and so forth. And then when my mom comes here and she says, hey, Nick forgot his bag, then this person over here knows that, hey, Nick, right? Okay, Nick must be on wagon N, so I'm gonna go here, and sure enough, I'm here making YouTube videos. So that way, the person interested in me will directly know where I am, because it limits the scope of searching for me to a specific block. This is exactly how partitioning works in DynamoDB or other databases like Cosmos DB, MongoDB, and so on. All of them do that. Now, they do it a bit differently, but the idea is that you have to specify a specific value. In this case, it is the first letter of my first name to be used as the partition key, and that's the partition key. And then the sort key that we're gonna see over here is just how data is sorted within this block of data. So if the sort key was the first letter of my last name, Chapsas, then because it's C, I would also be sitting pretty close to the start on the wagon because it's A, B, C. If it was Z, I would be at the very, very end over here. So that's the difference between the partition key and the sort key. The partition key tells you in which part of the partitioning that the database will do behind the scenes the data is, so you don't have to search a big enough scope. And the sort key tells you how the data is sorted within that single partition. And that's it. The identifier of complete uniqueness in DynamoDB is the combination of the partition key plus the sort key. This combination is what indicates complete uniqueness. Now, all this goes way deeper, but on surface level, just so you understand them, this is what you need to know. Now, in our case, we're gonna see how we're gonna use partition key and sort key, but it's a very good practice in your table to actually just call the partition key PK and the sort key SK, because you can have a fixed field for them, and then as you have different data objects in that same table, you can just use that same PK and SK fields and point through the property to the thing that is actually providing you the value. So I'm just gonna do PK and SK here. And then in settings, I could go with default, but I'm just gonna expand it for you so you can see. You have a different table class which optimized for different workloads and access patterns. I'm gonna go with default here, and then I have the capacity of the table. So you can either have on-demand capacity, so effectively your reads and writes will scale as your data asks for more of them and you won't get throttled as often. You can still get throttled, but it's way less often. And that is better for spiky workloads, but more expensive. And provisioned is when you say that I expect to have max 5 reads per second and 5 writes per second for this table. And if someone exceeds that, then, well, I haven't paid for it, so just throw an error. And then you can have auto scaling as well. So even though you can provision capacity, you can say that if my minimum units are 1, so roughly 1 request per second, or if it's 10, so 10 requests per second, then scale down my table all the way to 1. But as a target utilization threshold is being reached, so 70% of the capacity, then start auto scaling that table to be able to handle more up to the upper limit. We don't need any of that. I'm gonna go with provision capacity for both of them. I'm not gonna touch on indexes. The cost, as you can see, with 5 reads and 5 writes per second is roughly $3.5 per month, which is pretty cheap. And even if you go with 50 and 50 here, and this goes to $34 per month, 50 writes and 50 reads per second, it's not a low amount of load, so it's still pretty cheap. And then you can also have encryption at rest, meaning the data can be encrypted when they're stored in DynamoDB, and you can have the key being owned by DynamoDB, AWS, or yourself, and then some tags. And I'm just gonna create the table now, and the table will be created super quickly. So now I can go back to the code and actually start implementing my logic. So the first thing I need is to add the DynamoDB v2 SDK. Now there's 2 ways to approach this, the high level DynamoDB API and the low level. I'm gonna show you the low level as I always do, because I want you to know how to have full control of what you're working with. And now with that, I will be able to inject, and let me just delete that because it bothers me. I'll be able to inject a private read-only Amazon DynamoDB, which is the DynamoDB client, and inject that from the constructor and be able to call DynamoDB. So to register that, I can go to the program.cs, and up here I can say builder.services.add singleton Amazon DynamoDB, and I'm going to pass some configuration here to make sure I'm calling the right region. So I'm going to say EU West 2. Now my PC is authenticated against DynamoDB, so I don't have to deal with IAM roles. In your application, if you're planning to put this somewhere, you actually need to grant the appropriate permissions from the running application to be able to call DynamoDB and make the appropriate calls. I have covered that in previous AWS videos. You can see them in the AWS playlist. And now I have that. Now in the settings, I no longer need a connection string here. So I'm going to change this to table name, and I'm going to say customers here, which is the table name. And I'm going to create a settings object actually to put this in. So I'm going to create a quick folder, settings, and create an object called database settings. Arguably, I should have made that earlier, but whatever. So public const string key name equals database, which is the name of the section over here. So I can just reuse it. And then the property is the table name over here. So prop string table name. And this cannot be empty, so it's not nullable. And now with that, I can go to the program.cs and say builder.services.configure, and I can configure the database settings object and pass down the section. So config.getSection, and it's database settings.keyname. And that's it, meaning I can now go to the repository and private read-only I options database settings and say database settings over here and inject that. And I'll be able to access the table name now from this object. All right, so we have now everything we need in the repository, but I want to go to the customer DTO and change a few things. First, we're going to need the two properties I mentioned, which is the PK and the SK. So both of them go here. Now, both of them will be strings. And the reason why they're going to be strings, and actually the ID over here will also be string because GUID isn't really a type in DynamoDB, is because the PK is going to be the ID of the object, and the SK is going to be the PK, which is the ID of the object, meaning that I can enable point reads directly to an object even within the partition. Now, this is common if you just want to have your basic CRUD. However, it can get more complicated if you need more complicated data modeling. For what we're doing, it's absolutely fine. Now, what I want to do is add JSON property names to everything. So one for the PK, one for the SK, and all of that will be added because it's going to be serialized as a JSON object in DynamoDB. So let's go ahead and quickly add that. GitHub username. The case doesn't need to be camel case. I'm used to using camel case, but you can just leave it as it is. But I would say that you should have at least something that ensures a deterministic way of serializing the names, because when a property name changes here, you don't want to break how the contract is stored in DynamoDB. And now here I can implement create async and start with the first method, and everything with this low level DynamoDB SDK is request and response. So first we're gonna need a create item request. Now DynamoDB doesn't have the concept of create. Yes, you can create a table, a backup, or a global table, but you can't really create an item. You put an item, meaning that if an item with this PK and SK exists, then it will be updated, otherwise it will be created. So what I need is a put item request, and I need the table name, which I can get by the settings I just injected. So settings.value.tablename. And then the item, interestingly enough, is not just text or an object, it is a dictionary of values, a string and an attribute value. That's how the SDKs in AWS work. Now, to generate that, we need a bit of code. So first we need to say customer as JSON over here and serialize the JSON. So serialize the customer to JSON. Then we need to have the item as a document. So document.from JSON and use the customer as JSON that we just created. And then we need the item as attributes, which is the item as document dot to attribute map, and that's it. And now I can say item equals item as attributes, and I have my request, and then I can say response equals DynamoDB dot put item async, pass down the create item request, and of course we should await this, and then say return response dot HTTP status code is okay. So if it's okay, then all good. And that's it. That's the code to create, and this will actually be the same to update the full object. Now I could just point to the create async method, but in case you want to change the behavior, I don't want the change to the create method to accidentally change the behavior of update. And I'm going to change that to update item request. Here we go. Now let's do the get. So var request, and we're going to have a new get item request, which has a table name, which is database settings.value.tablename. And then the key here, as you can see again, is a dictionary of string and attribute value. The reason why it's that is because there isn't one individual key. Yes, it could be if you're not using an SK or a sort key, but the key is actually the PK and the SK, because this is a point read. We say we want this specific item. So key equals new dictionary, and it has two values. The PK, which is a new attribute value, where S, because we're dealing with a string, if you want a different thing like a number, you have to go with N, and there's different types that you might want to pass down. But in this case, it is a string, so it's id dot to string, and the SK is the same as well, same thing to string, and we pass it down. And that's it. We have our request. So we can say var response equals await DynamoDB.get item async and pass down the request, and then say that if response.item.count equals 0, so if there's no attributes of the item in that dictionary, return null, so the thing doesn't exist. Otherwise, deserialize it, which is the opposite of what we did before. So var item as document equals document.from attribute map, and then response.item, which is an attribute map over here, and then return JSON serializer.deserialize to a customer DTO, and it is item as document.to JSON. And that's it. And now we have the get. I'm going to skip the get all. In fact, I'm going to comment the get all out, both in the repository and also in the interface of the repository. And we're gonna go straight to the last one, which is delete. Now, a delete item request, which is a new delete item request, looks a whole lot like the get item by ID. We can actually copy that, and it's the exact same properties we need to pass down, because we say delete that specific thing, and the details to identify it is the PK and the SK. And then just to wrap this all up, we say response equals await DynamoDB.delete item async, pass down the delete item async request, and return response.http status code is okay, and we're good. Now, because I removed this get all method, I have to go to the service and also comment that thing out. So I'm gonna remove it from the service and also from the service interface, and I have to do the same in the controller, so that endpoint goes away. I'm gonna explain why after I show you the thing actually working. I just have to change my mappers a bit, so this goes here and GUID.parse goes here, and that's it. Now I've changed everything I needed to support DynamoDB for my system. So I'm gonna go ahead and run this API now. And let's go to Postman and try to call these endpoints again. So let's see if I can create myself. And sure enough, I can. I have been created. I can create more versions if I want to, and it all works fine. I can go and get me by ID, so I can call that. And sure enough, this is calling DynamoDB. This is getting my data from DynamoDB. I can update me, so I can change the date of birth to a different one. So here you go, update it. I can also delete it. Now I created two, so I'm gonna delete one of them, delete it successfully, and I'm gonna show you the other one, which should still be in here. So I'm gonna click here and say explore table items. Let me just delete that. And as you can see, this table has only one item. If I open it, then you can see the PK, the SK, the ID, the GitHub username, all the data is here. And if I change them, they will be reflected. So not only did I integrate with DynamoDB, I also migrated to DynamoDB very, very easily. But you might be wondering, why did I remove the get all method? Well, here is the problem with partitioned NoSQL databases. If you remember the train wagon example that I showed you before, the optimization we did is we removed what is effectively scanning of all the wagons to find the data. So if I was to implement get all, I would have to go and ask every wagon again and ask from everyone to give me their names and then return them back. This process in general in databases like DynamoDB or CosmosDB is a no-no. You don't want to scan your table, and the reason for that is because it's extremely inefficient, and it gets significantly slower as your data becomes more and more. You have to get all the data by each partition, then aggregate all of them, and then return it to the user. And it is not something you want to be doing. Now, there are databases that are very good at doing just that, and some NoSQL ones actually have dedicated query nodes. However, you have to throw a lot of money to the problem, and it's not a problem that you need to solve that way anyway. There are other ways to architect your solution and make something else that can return you all that data if you need them in a pretty efficient way. Now, if you're interested in how I can actually data model all this, again, in AWS to provide this same experience and bring the get all endpoint back, leave a comment down below if you're interested in that architecture style of video, and I'll make one. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making this possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. and I'll see you in the next video. Keep coding.